Hello everyone. So we're just going to continue on with the perpendicular distance formula, and we'll just play around with some more examples. So here's one to try. Find if 1 is equidistant from the lines x plus 7y minus 3 equal to 0 and x minus y plus 1 equal to 0. Okay, so you have to find whether it's the same distance from both of them. So of course, the only way to do that is to put both of them into the formulas and see where we come out with an answer at the other end. So let's have a go at this one. Let's have a go. Let's do 1, 1 with x plus 7y minus 3. And we'll do 1, 1 with x minus y plus 1. So again, label your A, B, and C. So absolute values over a squared plus b squared. And we've got looking good so far, but we'll see. Okay, so we're getting the square root on both sides. So what is our rule? It's a times x1. Okay, so it's 1 times 1 plus b times y1 plus c. I'm just going to go with it's a minus anyway, so I'm just going to leave it at that. And then on this side, we have, what do we got here? We have 1 times 1 plus 1 times minus 1 plus 1. So it doesn't look the same, but we'll give it a go. So what have we got here? We've got 7 7s 49 root 50 over, what have we got here? We've got 1 plus 7 minus 3, that's 5. Absolute value doesn't matter there, but anyway. And here we got, let's see, we've got here 2 minus 1 plus 1 is 1. Sorry, it's 1 minus 1 plus 1 is 1 over root 2. Right, are they the same? Well, now, of course, calculator is going to be checking because they don't look like they're the same, but let's do our trick. Let's multiply both of them by root 50. So that gives me 50 on the bottom, and that gives me 5 root 50 on the top. Okay, 5 root 50, that's 5. Let's see, that's 2 by 25. So 2 over 25 is 1 over 5. Yeah, they are actually the same. Yeah, they're the same. Okay, I'm just going to double check on the calculator. 1 over root 2 on the calculator comes out as root 2 over 2. And 5 root 50 over 50 on the calculator comes out as, would you believe, root 2 over 2. So yes, they are equidistant. Yay! Perfect. Okay, so we'll try another one. Oh, that's a bit colored. Try another one. I'll try. Okay, there. Right, we'll try another one then. Right, if the point minus 2 and a is equidistant from 4x Find A. Okay, so it's the same as the last one, except we have less information to go on, except the fact we know the two answers have to be the same. So you can get the idea with this one. It's kind of a more of a, I don't know, it's just more of a little trickier one. Anyway, I'm going to give you a countdown on this one. So you've seen the previous video, look back over it, and all we're going to do is get the two equations, make them equal to each other, and solve for A. Happy days. Okay, 3, 2, 1, pause. And we're back. So let's set out our stall here. We've got 4x plus 3y minus 3. That's A, B, and C, and minus 2 and A, x1, y1. And then here we've got 12x plus 5y minus 13, and we've got minus 2 and A, B, C, x1, y1. So we're going to fill out our formulas and see how this goes. So A times x1 plus B times A plus C over A squared plus B squared is going to be equal to, that distance has to be equal to this one, okay? 12 times minus 2, 5 times A minus 13 over the square root of A squared plus B squared. Okay, so let's tidy this up as much as we humanly possibly can. Okay, we've got a, what do we got here? We've got a 3A and we've got a minus H, so it's 3A minus over, that's 5, minus 24 plus 5A, so that's minus 37, so that's 5A minus 37 all over 13. That's 144, and 25 is 169, square root of 169 is 13. Listen, this is a simple enough sum. Okay, do it whichever way you want. 13 times that side equal to 13 times 3A minus 11 is equal to 5 times 5A minus 37. 39A and 25A, that's going to give me 14A on this side. And that's going to give me, what's that, minus 143. That's a plus 143. And that's a minus 185. That's a minus 42. So A is minus 3. Okay, so hope you got that. Really hope you got that one, lads. Sorry. Sorry now, my lighting situation is not improving that much, but I'm hoping that I'll just quickly let you look at that one again. So the A in for the unknown, making the two sums equal to each other, a bit of algebra, happy days, you got your answer. A is minus 3. Okay, right. Let's try another one. So we want to show that 3 and 4 and 9 and 3 are on opposite sides of 3x plus 4y minus 36. So remember, what's our trick? If they're on the same sides, then when I get this, so when I use the perpendicular distance formula without the absolute values, both will be positive. Whereas if they're on opposite sides, one will be positive, one will be negative. That's the trick. So again, we've got two sums to do. Let's do them. 3x plus 4y minus 36 with 3 and 4. And 3x plus 4y minus 36 with 9 and 3. Okay, so we've got A, B, C, x1, y1. A, B, C, x1, y1. Okay, so we're going to do this twice, but remember, we're not using the, what you call this time, we're not using the absolute values part of the formula. This, okay. So let's give it a go. A times that, so that's 3 times 3, plus 4 times 4 minus 36 all over the square root of 3 squared plus 4 squared. Okay, that's going to give me, that's 9 plus 16 minus 36. That's going to give me minus 11 over 5. So that's negative. So we are expecting this one to be positive if they're on opposite sides. So let's do it. 3 times 9 plus 4 times 3 minus 36. Okay, 3 times 9 plus 4 times 3 minus 36 over 3 squared plus 4 squared. That's 3 nines are 27. 27 and 12 is 39 minus 3 is 3 over 5, and that's positive. So one's positive, one's negative. They are on opposite sides. Okay. So again, there you go. Nice little example there of one to do. Now, let's try another one. Okie dokie dokie. So, okay. So, 4x plus 3y plus 1. Okay. And we need to find a parallel line that is 2 units. Find 2 parallel lines that are 2 units away. Okay, so we've looked at this one before. Okay, so again, this shouldn't be too much of a taxing problem for you. I'm going to give you the pause and give you a chance to give it a go. Okay, so 3, 2, 1, and pause. And here we go. So what's our generic formula for any parallel line today? So it's going to be 4x plus 3y plus k, isn't it? Where k is any number. Okay. So we need to find a point on that line, and then we're going to look from that point to the k to see what possible values will work. So what are we going to do? How do we find a point? Listen, listen, I don't know whichever way you want to go for it. Let's find a point in this line. We'll go with a fractioning one, but I want to try and find an easier one. So let's have a look. I'm just going to quickly do it out here. So well, that's an easy one. If you want to find a quick point, minus 4 plus 3 is minus 1. So if x is minus 1 and y is 1, then that will generate a minus 1, which is perfectly fine with me. Okay? So minus 1 and 1 will work fine. The other option is let x equal to 0 solve for y, let y equal to 0 solve, find one of them, but they're going to give you fractions, and that's going to give you a headache. So try and go for one, especially when you can see that the numbers are easy enough to manipulate to find one. So that's the point I'm going to use. Okay. So here is my generic equation. And here's my point. A, B, C, and x1, y1. Okay. And that has to be 2. Okay, it says minus 4 plus 3 is minus 1. So k minus 1 over 5, the absolute value of it has to be 2. Okay, so what are we looking for here? We're looking for a value of k that when you divide it by 5 gives you 2. Okay, so obviously 11 minus 1 is 10. 10 divided by 5 you give me 2. But we need another one. Minus 9 minus 1 is minus 10. Divided by 5 will give you minus 2. There's your 2 possibilities. The other option is cross multiply, square both sides, and solve as a quadratic. Okay. So yeah. So what are we looking at here? We're looking at So k can be, what do we say again, 11, or k can be -9. Okay, so there's two possibilities for k. Okay, no pun intended, but there's two possibilities for k. Okay. So listen, before we go on to the next one, I suppose it's good to kind of just look at where we are so far. Okay. Okay, so listen, I'm trying to think of any other option you could go with. Listen, with these ones, you could, if you really are stuck, just cross multiply. I just, because I know it's very easy to do it by inspection, but I know there's some people thinking, no, sir, I've learned it the other way, so I'm doing it the other way. Square both sides. K squared minus 2k was a +1. Bring that over. And what are we looking for? There's the other way of doing it. Okay, cross multiply gives you that. Then you can either do that by inspection or just square both sides and then solve it as a quadratic. Your options. You know, you're big boys, you know what to do, type of thing. Right. So we'll do one more and then I'll let you go on this. Okay. Let me try and find one for you. Yeah. So -4 and 2. I want you to, let's say we're going to write down any equation that goes through this point. Okay, and then we're going to find two equations through -4 and 2 whose perpendicular distance from the origin is 2 units. Ooh, okay, this one's a bit tougher. Right, it's a bit more of a mouthful on this one, okay? So I'm going to give it a count of 3 and give it your best little shot, Rooney, and then we'll do it together, as the man says. Okay? Right, 3, 2, 1, go. Okay. So we need to find two equations through -4 and 2 whose perpendicular distance from the origin is 2 units. Okay, so let's have a look. We have a point of -4 and 2. We don't have a slope, so but we can still pop it into the formula. So we have -4 and 2. That's your x1, y1, and we have a slope of m. Okay, y minus y1 is equal to m on x minus x1. Okay, y minus 2 is equal to mx plus 4m. So let's get them all together. What do we got here? We've got mx minus y plus 4m plus 2 equals 0. So that's our formula of any line that goes through it. As long as you know the slope, you just put the m's in there and suddenly you've got your formula. That's a now you could try and by inspection find one that works. You know, something x plus something y equals 0 and find out, you know, something that works. Okay. In fact, it'd be pretty easy. Minus 4x plus 2y would work. Okay, that would work. Okay, but I'm not going to go there because I want a generic one here. So all we know is that this has to be the kind of, whatever you want to say, has to be a way it's going to work type of thing. So what do we want to do? We want to write down the, we want to find the equation of 2 points through that, okay, whose perpendicular distance from the origin, for 2 equations that go through that point, okay, whose perpendicular distance from the origin is 2 meters. So if you don't mind for a second, I'm just going to visualize this. No harm. Minus 4, 2 is around there. Okay. So, and there's the origin. So we want 2 lines that go through that point, and the perpendicular distance from those lines to the listen, you could like be looking at something like the going this way. Okay. One of them would definitely go this way. Okay. That's for sure. Okay. Definitely one would go that way. So, because that would definitely give you a 2, and that would just be y equals to 2. That'd be an easy one. Okay. Now the other one, y is equal to 2. I'm wondering, would that be a perpendicular? That's not perpendicular distance from the origin. See, that is a perpendicular distance. You could x equal to 2. I suppose that would work as well. Okay. I'm just wondering, is there any other possibility? Probably is. Okay, right. So listen, let's have a look. Okay, so the origin is 0, 0, and here's my equation. Okay, so this is my A, my B, and this whole thing is my C. Okay, x1, y1. Okay, so we have m times 0 minus 1 times 0. Sorry. Plus minus 1 times 0 plus 4m plus 2 all over a squared plus b squared. So that's the square root of m squared plus minus 1 squared. So, and that has to be equal to 2. So that's really what we're saying, okay? That whatever formula it is, that its distance from, we have everything we need apart from really the slope. Okay, it's a bit of an unusual one, but we go with it anyway. Okay, so how are we going to figure this one out? Well, let's just try and tidy this up and see, I can see straight away it's going to give us something to work on. It's going to give us a quadratic-y type of situation, because we'll have a root on one side that you can't get with a square the other side, that type of way. But I'm just trying to play ahead of me in my head. So let's try and work this out. So what have we got here? We've got a 4m plus 2, because both of them are going to, so we have the absolute value of 4m plus 2 over the square root of what? M squared plus 1 equal to 2. So, run out of space. I'm going to do it up here. Okay, so again, apologies. So I'm going to bring this up here and then just feed it down. So that's going to be multiply 2 root m squared plus m is equal to the absolute value of 4m plus 2. Okay. So we're going to have to square both sides. Squaring this side is easy enough. Squaring this side is just going to be, 4 times m squared plus 1. And this is going to be square the left, square the right, multiply them together, and then plus 4, isn't it? Now, tidy this up and we'll solve, because I see m squared, so that's 4m squared and a 16m squared. So I'm going to get, and then I've got a 16m. So I'm looking here at, and then the 4s will cancel. So we're left with a 12m squared plus a 16m equal to 0. Factorize out. We can divide across by 4. So that's 3m squared plus 4m equal to 0. And that's going to be m on 3m plus 4. M is equal to 0. And m is equal to minus 4 over 3. So if m is equal to 0, oh, Jesus, where are we? If m is equal to 0, then that becomes 0. That becomes 0. And we have, what have we got? Y is equal to 2 is one of them. Okay, which is what I guessed at the start. And then if m is equal to minus 4 over 3, then the other one is going to be minus 4 over 3 times x minus y plus 4 times minus 4 over 3 plus 2. Okay, so minus 4 over 3 times x minus y minus 16 over 3 plus 2 equal to 0. Multiply everything by 3, you're going to get minus 4x minus a 3y, or 4x plus a 3y. Multiply by 3, you're going to get a plus 16, and you're going to get 10. There we go. Equals 0. So that's your second one. Hope you can see that. And that's a tough one, lads. But that's where you're going with some of this. Okay? That's where you're going with some of that. So I want to go through it all again very, very quickly because it's a very long video, but it's worth going. All you have is this bad boy to go on. From that, you can either create an equation or get a generic one by just subbing it in to y minus y1 is equal to m on x minus x1 with just the m. That gives you a generic one. Now we need to find the two possible values of m. So sub that in, reference into 0, 0, make your your perpendicular distance equation equal to 2, solve it for m, pop them both back in, you get your two values. Best of luck, lads.